Well, hello and welcome. I'm delighted to once again welcome my colleague and friend Rainer Viehweger, who we've done a number, haven't we, of different recordings now on various aspects of, biology, psychology, global scaling. And I think we're going to do another one today on kind of drawing a lot of that together with how we see life beginning, the origin of life. So, Rainer, do you want to take us away with how did life begin?
Yeah, it's very interesting. As I know it for now, or I see it and understand it right now, that with my friendship to Hartmut Müller, who always says that there's no beginning and no end to life, because everything is alive. And life cannot be created, nor can it be destroyed in a certain way. But this is an aspect of philosophy and physics and mathematics put all together. And I think it also tells us something about how we should change the worldview and let's say our place in the universe, who we are and what we are doing here. And we said earlier, as Hartmut always says, we are the eyes and the ears of the universe. Among others, of course, there are also dolphins and other highly developed animals, and I'm sure also other living beings that we may call beings in organic life on other planets somewhere. But yeah, I think that's part of our role here in the universe, that we help it to become self-conscious and learn about itself.
Yeah.
And we all know these times are very important. We are making important shifts, changes to how we create the near future for our civilization, for our societies right now.
Yeah.
And we can feel that in the many changes that are going on right now. So there is a huge density of events that happen every day. And this is always a sign that the fractal time, of course, which is also fractal, approaches or goes through a very dense area with attractors that promote change. And that promotion of change is not something that is predictable in terms of where we go, but it gives us the options, the maximum probability for making changes. But then into which direction we go depends on our consciousness, on our thoughts, and on what we really want as humans, how we want to live. And of course, to know that, we need to know who we are and what life is.
Yeah.
I've also read lots of books by this Professor Nick Lane from London, who is a biologist and who really wrote interesting books about how
life? Yeah.
our eukaryotic cells were formed from the world of bacteria. So why did it happen that bacteria started to come together and to ingest each other and eat each other to form another life form, which he says the first predators. So when a bacterium had eaten the other without digesting it, otherwise it would not have survived. And so why did this happen? And for me, this is, and then I will work on that and try and write it down in the next book that we are preparing. I think it's a normal way of evolution, and it's a so-called scaling process. Because if we think about geometry, three-dimensional, and then we go into four-dimensional geometry, which you also wrote down in your book, where you talk about the tesseract and the hypercubes, where a cube is embedded into another cube. And I think that's the process that happened when bacteria formed a next step in evolution in another dimension, where organelles, which were bacteria, started to live in other forms of bacteria and then work together cooperatively. And it's very interesting. So Nick Lane also explains in his book, and some of the sources he uses do the same thing. It also explains why there would be a need for sex, the two sexes.
Yeah.
And that's also very interesting, because the information to produce the most important proteins for energy production in those eukaryotic cells is maximally preserved. So when an egg cell is given on to the next generation from the mother, the DNA and the whole mitochondria who do the energy production in our cells, they all come only from mother's side, not from father's side. Sometimes a little bit of mixing happens, but if it is too much, the embryo will die.
So there must be a reason.
There is a reason. There is a reason, because the DNA for coding those proteins who run the electron transport chain where the ATP production happens must be maximally preserved. And when a female baby is born, the egg cells are already there, protected in the ovaries. They don't have any metabolism. They just are there and wait to ripe, and only a few cells go to that stage during the woman's life later on. And this is the way how over the generations that DNA, that template, is maximally protected and given on to the next generation. And it's totally different in males.
Yes.
Because we have that nuclear DNA. And there are many changes in the nuclear DNA. We all look a little bit different, just like the color of our eyes, the shape of our nose, and whatever we talk about. And this is somehow all coded in a variety of many genes. And in a male person, the sperms, they divide again and again and again and again, and there is influence from the environment, how things are passed on to the next generation, not only in the DNA, but also in the epigenetics around it. And this gives us the highest variety of things that can happen, in opposite to the most preservative.
So that's the female, male
in the mitochondria. Yes,
yeah.
and it's important that we have healthy mitochondria because they make our energy.
Energy, yes, yes.
Yeah, and of course we could also see that step of evolution from prokaryotes to eukaryotes in terms of energy production.
Well, that was the big leap, wasn't it?
That's a leap, and that was necessary because bacteria have a certain surface, and all the ATP production happens on the inside of the membrane.
Mm.
So they and that surface is limited in a bacteria. So and you cannot, if you only, because it's mainly it's a cylinder, or sometimes it's a ball-like structure, the bacteria. So there is a ratio. When you increase the surface area a little bit, the volume increases a lot. So the metabolism is also increasing in a bacterium, and then you simply cannot make enough energy only on the surface of your membrane. That's why nature had to invent a different way of producing energy, increasing the surface where ATP, the membrane surface where ATP can be formed.
That's the convolutions in the...
And yes, and that's why we have so many mitochondria, because they are mainly, on the inside, they are mainly membrane.
Yeah.
Membrane surface. And it's in one cell, it's probably like the size of a football field.
Oh, yeah. That's where all the transfer takes place, isn't it? All the energy production.
Yeah.
So maximizing.
So for me, that's a scaling process.
Yeah, of course.
Which didn't happen randomly.
No.
And it had to happen once, because when it's then there, it happened. And it may be that you still find some microorganisms somewhere, and you can read about it in Nick Lane's books, where you have kind of intermediate stages, how that may have happened and how it works. So there are so many interesting people involved in who thought about that. There is another lady, if I would knew her name now, but you can look it up in the book, and I actually will find it out because it's so important.
Okay. Not the lady that did experiments.
A researcher from the US.
Yes.
And, I should
found changes in the genome. Yeah.
Of course, I should find her in my library. Now I have to go and look on my shelf because I bought the book. Oh yeah, it's Lynn Margulis.
Oh, Lynn Margulis, yes. She 1960s, yeah.
In the 60s and later on a little bit. And then you find the world is so small, because there is this astronomer, Carl Sagan. You may have heard about him.
Yep.
And they were both married.
Yeah.
So the world is so small sometimes. And,
yeah.
Yeah, and they both all had interesting ideas. about the origin of life. But if we really want to go back to the source why we say that everything is alive, then I have to go back to Hartmut Müller, who always says, and I told you before, the origin of life is the number continuum. So it's numbers that create life. And there's also a reason for it. And I visited a new seminar with Hartmut Müller, where he again stated that it is numbers that create matter. And it is a certain number that is doing it. And he said that finally he figured out what the role of pi is in the universe.
Okay.
So the number pi is the one that creates all energy that exists.
Oh, I thought you were going to say Euler's number, so that's interesting.
So we know that pi is also a transcendental number.
Yes.
And it's part of a circle. And pi closes the circle, but it doesn't do it with a beginning and an end because of its transcendency. It's a continuous cycling in the circle without beginning and without end. And it's the transcendency of pi which does that. And maybe we talked about continued fractions.
We did do a presentation on that. Yep.
And we saw the continued fractions of the golden ratio and Euler's number. And I've now seen the continued fraction of pi. And as a difference to Euler's number, which contains every single number in the universe that exists and every ratio, every musical ratio. In addition to that, pi, the continued fraction of the number pi, contains multiplication.
Yes.
And that type of multiplication energizes the whole system. So that's the reason in the structure of number pi and its transcendency that it closes the cycle without a beginning and an end and starts to repeat it again and again. And it does it every time. So it creates all cycles, the energy. And Hartmut Müller said on his seminar that we know that Euler's number is the universal stabilizer. But without the energy of pi, there's nothing to stabilize for Euler's number.
Right, so they're related, both needed.
They're both needed.
Different functions. Yeah.
And they have different functions. Yes.
Wow. I don't think you've ever said it in those terms before. So
no, it's new. It's new. That's why I said we've got some new insights.
Fantastic.
This is a totally new approach to see things. And of course, this is the origin of how all types of energy are created. And all those particles also.
Right. Well,
and this is something, when we go back to the biologists again, they are already conscious that there is electromagnetism involved.
Yeah.
in the formation of plants and fruits and organisms.
Yeah.
But they haven't done the last step in their thinking yet. Physicists have already told us that particles like electrons and protons, which make up the atoms, are waveforms.
That's right.
Like oscillations, vibrations. And what is still missing in biology, but maybe also in other fields, is that everything that interacts is an interaction of oscillations.
Mm.
And then the finding new structures is the result of oscillations interacting, creating interference patterns, creating more complex oscillatory systems. And in addition, it always wants, and that complex system always wants to get to its lowest energy state. So the direction of evolution is given by the interaction of oscillations. Darwin called it natural selection,
He did.
which it is, but he didn't explain why the shape,
yes,
the shape of the birds. I don't know the name in English. The bird's mouth, beak. Yeah, the beak is adapting to the flower.
Yeah,
to the flower shape. Yeah, it's because oscillatory systems interact with each other.
Yeah, that's completely missing, I think, and even in the new biology that's coming in now,
Yeah, that's something that is still missing.
Yeah, they don't talk about oscillations so much. They talk about bioelectricity and goal directedness.
They do. And in one of his books, Nick Lane writes, and in the epilogue at the end, that the 21st century in biology will be a century of electromagnetism.
Yeah.
Yeah, but this is not the last step. So we need to go further with that. And then we find explanations for much more.
Yeah, the difficulty is the siloing of the different sciences, isn't it? Biology doesn't tend to talk to physics, and
yeah, that's necessary that we do it. If we don't, we don't develop.
Yeah,
we don't go any further. It's like in medicine. Yeah, if the eye doctor does not know what the orthopedic doctor does.
Yes.
And then sometimes when I tell people, your back pain is related to your eyes, then they look at me. How's that?
Yeah, that whole energetic connection.
It's not only energetic. It's simply mechanic. Because if one of our eye muscles is not working well, and we want to focus our vision, our look to something, we have to turn our head a little bit.
Oh, of course, yes.
So with turning the head, there is a compensating movement that goes from your skull to the cervical spine, and from there it goes to the shoulder girdle, and from there it goes down to your pelvis, which starts to rotate. And at the end, they tell you have a difference in your length of your legs.
Yeah.
Which isn't true. It's
an adjustment.
It's just an adjustment. And it's the same with your teeth and so forth.
The biomechanics of that. Yeah.
So, And then, of course, it's simply the mechanical level, the biomechanic level. But of course, then there are fascia problems, and we know that in the connective tissue and water, we have the meridians running. So it will also cause an energetic problem. And with that, it will cause an energetic problem to the related organs, to the metabolism in those organs and cells. And yeah, so it's all interconnected. So we really have to see the body in a different way. As a very complex oscillatory system that is connected on so many different levels.
Yes.
Yeah.
I've recently been reminded of that myself, because I don't know if you know, but I hurt my shoulder very badly, and you know, the limitations I've had, I am compensating on the other side, and everything hurts, and it's just, but there's also the mental emotional impact of not being fully functional, and you know, the fear, and I suppose just generally feeling quite just under a cloud, if you like, of not being able to function. But yeah, so definitely my oscillations are a bit off at the moment, I would say.
Yeah, and it's not only the other side that compensates. It's
the whole body, isn't it?
It's the other side in the hip joint.
Yeah.
It's the other side in the ankle joint.
Yeah.
So it just and then the muscles in your feet, on your foot soles down there, they will also adapt and become harder and painful. And then you do reflex zone massage techniques on it and so forth. So
yeah, I am having reflexology and, you know, various treatments to try and bring the functioning back, but it's been a slow journey. But it reminded me, actually, what you said there about the body is able to compensate in many ways, and biology in general is a stochastic system which will find its way to the end goal, whatever that is, say developing 2 legs and 2 eyes, whatever, regardless of the route that is normally taken. You can actually demonstrate this in organisms where you move their eyes, like tadpoles, and you move their eyes, and they normally, to form a frog, have to move the eyes to the front, and it will still move the eyes to the front even if they were on the side of the body. And so there is some sort of energetic push, if you like, and I guess that's what you're saying, the patterning from this resonant system, which has this goal directedness towards the end goal, which is whatever it is. In a human being, obviously it's this form, but in other animals, even single-celled organisms, it's a different end goal. But nevertheless, there is this, I guess you would say, intelligence in the system.
Yeah, sure.
That's what Nick and Michael Levin have been saying, that there is a cellular intelligence. That you could go even further and say there is a universal intelligence at even smaller scales. And that's kind of what you're saying, isn't it? This whole...
And it's so interesting that all these subsystems in a bigger system can work together without disturbing each other.
Yeah.
Because when we look at Euler's number,
yes,
this special transcendency of Euler's number is making sure that all these processes can work together without hurting each other.
So maybe
otherwise, if they would, then energy would build up.
Yeah.
And at the end, we would just ignite ourselves in a certain way and burn.
We would burn, crash and burn.
Because we would build up so much energy that becomes amplified by building up.
Is it worth reminding people what you mean by transcendental, and just if people haven't watched our previous videos or read any of the books that you've written?
Yeah, it's everything that is related to resonance
Yeah.
is about relationships of resonant systems to each other. And resonance is created by whole number or rational relationships.
Mm.
And we also have those irrational numbers, which in their fractions, they don't have an end.
Mm.
But the irrational numbers are not the best numbers to prevent resonance that is destructive, because sometimes irrational numbers are roots of other numbers. And if we square those roots, we can turn them into rational numbers or even whole numbers, like the square root of 2 or 3.
Mm.
And then destructive resonance is not prevented anymore. And transcendental numbers are also irrational numbers, but there is no way to turn them into a rational number.
Yeah.
This has been proven mathematically that you cannot do it. So every power of the number e or pi, for example, may it be a whole number power like e square or something like that, or even the square root of Euler's number e, they are all transcendental.
Yeah, every iteration. Yeah.
And every relationship between atoms that is a power of e or a power of pi, many times maybe, then that relationship is always avoiding destructive resonance. So all these systems and subsystems which are embedded into each other can work together without amplifying each other and destroying each other.
Mm.
Of course, this also, you need resonance to pass on energy and information, but only for a moment, for a short, limited time, before the amplification gets so big that it leads to destruction.
Yeah.
So you go into resonance and then you leave the resonance again when the energy exchange has happened.
So it's a momentary transfer.
Yes.
Yeah.
Yes.
Wow. Exciting.
This is how nature works. Yeah. But if you want long-lasting stability, you want relationships that are transcendental numbers.
Yeah, because they avoid the destruction.
Yeah.
Of resonant.
Yeah. If you want in very intense energy exchange, you build up that resonance, but only for a short time.
Yeah. One wonders if that's the basis of evolution.
Yeah, sure.
Like, the energy obviously has to exchange to increase complexity.
Yeah.
Yeah. Yeah.
The more when we look at the spectrum of oscillations, we have very slow ones, where we could say the slowest circle or cycle is not even seen as a rotation, because we see it as space, because it's so big. That would be the size of the visible universe. So traveling that around takes ages. So it's just space for us, because it would take so much longer than our lifespan is. So 100 years is not enough, but even 1 billion years is not enough.
No, to get around
even on the
space.
speed of light.
Yeah.
So that's why we see that as space. But when the cycles are smaller and faster, and they're spinning very fast, then we can see the spinning, and we can see the rhythm of it, and we experience it as a spinning with a time period of one cycle. And when and all those different sizes of cycles, they are embedded into each other everywhere, and they have to work together with each other.
Yeah.
And this is how those harmonic oscillatory systems create themselves, because the harmony is in the transcendency of Euler's number. And that's why it is that shape. And it's also, by the way, that pattern which uses least energy.
Yeah. Yeah. I think we looked at that before. You had a lovely diagram for that.
Yeah.
The waveforms,
We looked
where the nodes are, isn't it?
Right. Yeah.
Yeah. Yeah, it's fascinating.
And then the amazing new thing was, I told you that Hartmut told us that pi creates the cycling motion. And then first it does the slow, long-lasting cycles, and then it gets faster and faster, scaling up to ever faster ones. And then there are two stages where there is a kind of an inertia where it doesn't want to go further. And these two cycles are the cycles of the electrons and the protons.
Hence, they're fundamental.
Yeah, yeah.
Okay.
And there is a kind of resistance where the cycles don't want to be faster. And then between the two, the relationship of the seventh power and the square root of the Euler's number E stabilizes the ratio between the two to make atoms.
Yeah, I don't remember ever seeing that written anywhere.
No, that's
when I studied.
That's totally new. I've got this information
fantastic.
6 weeks ago.
Wow. Okay.
Yes, and that's the genius of Hartmut Müller figuring that out and prove it, or describe it at least mathematically in a way that it makes sense and is easy to understand, and it doesn't need pages long equations which nobody understands.
Nobody understands unless you're a mathematician. Yes.
Because everything that is genius is simple.
Well, ideally, yes.
Yeah.
And
razor, of course, this simplicity,
yes,
creates unimaginable variety of combinations, because everything is in there. So pi and E, both numbers, contain every other number that exists.
Okay.
And it can create everything that we cannot even imagine.
Even things that haven't come into being yet.
Yeah, it's already there in the numbers.
Yes.
In the number relationships, because those number relationships, they exist independent of us. They are always there. So man did not invent numbers.
No, indeed. No, they were already present.
Yeah,
We
numbers are
describe,
always present, and
yeah,
Hartman says they are cosmogenic.
yes. Oh, I like that word, cosmogenic. Brilliant.
Yeah,
Oh, wow. Okay. Yeah, they describe the fundamental nature of the universe, and but we want to know, when did the universe begin, don't we? We want to know, it was the Big Bang, the origin, and but you're saying no, it's always been present. It's
it's
just,
always been present, and
yeah,
some local things do come into existence.
yes,
Yeah, like we know or we think that our sun is a star that is 4.5 billion years old,
mm,
and it will go through its evolution and become bigger and red in a couple of billions, and then be destroyed at the end, and then we will be gone. But that's a local process.
yeah, that's happening in space-time.
And then
Yeah,
it will happen again elsewhere at a
yeah,
different local time
yeah.
again.
Hard for us humans to get our head around infinity and the idea that nothing has a beginning or an end when we live in a finite universe where we have physical things that live and die, and it's really hard for us to understand this.
Yeah,
So I think anybody that promotes a simple
yeah,
way of putting this over, like yourself, like Hartmut, I
yeah,
think is really valuable, and I think that's the benefit.
yeah. And I think that's important for us for our near future, that we make the right decisions
Yes,
if we want to uh, not destroy the planet we live on.
indeed. It's a timely reminder, actually, of, you know, our responsibility in a way to, as you said at the beginning, what we imagine and what
Yeah,
we create through our imaginings. We do have a way of guiding the
yeah,
way
yeah,
evolution is going, and
yeah,
therefore we should take good care of what we think.
yeah. And these types of knowledge can help us to develop other forms of, uh, let's say, time traveling or telepathy,
Yeah.
information exchange, which
Mm.
is much more an exciting area of science fiction than putting a chip into our brain or a fuse with a robot-like structure, which is a kind of very mechanistic
Yeah.
and yeah, it will not take us anywhere else.
So, do you know what occurs to me at this point is, talking of mechanistic, what's AI all about and where are we headed with that? Because it feels like at the moment it's just going to be, all doom and gloom and taking over jobs, and the
Yeah,
idea that
which is nice, which is okay. I would think if we
liberating us,
use
maybe.
it if you use it the right way.
Mm.
If For me, this whole AI is just another level of uh, computational support.
Yes.
Yes,
Yes.
and if it will take away jobs, which in my eyes is okay, because we don't need to be here and do stupid work, like sitting in an office and calculate the taxes of other people. So
Yeah.
no, yeah, our lifetime is much more worth other things, being creative,
Mm.
being communicative, be there to grow up children, for example,
Yeah.
be there together with friends. So it doesn't need to mean that if you are not working in your office anymore, that you don't have money to make a living. So that should change.
Yeah, I think that's the dialogue at the moment.
Yeah, that should change.
Yeah. I just wonder whether people are ready for the speed of this change, because it's going to happen within a generation, isn't it? And
yeah, that's why we live in such an exciting time where the density of changes is so high. Yes, and things happen, and people will be ready. Who are not will probably in a certain way and this is 1 or 2 generations, they will simply die out, so to say, in a normal way, without even being left behind. And if we think about life, then if we die, life seems to not have an end. It's just in the next period.
Yeah, that's hopeful.
With life going on without that physical body.
Yeah, I think
it's
that's
hard for us to grasp, but some people who had near-death experience, they know.
it's not.
Yeah.
No explanation for that materialistically, but there is if you understand the dynamics. Yes.
Yeah.
And I think that's the message of hope for all of us, is that it's not the end, it's just a transition. And
yes, and when we say that numbers create even a time, then there's no beginning and no end.
Beautiful. Do you think that's a good moment to tie things up? And I guess it's kind of where we started. It's just nicely circular.
Yeah.
Which, given what you've been talking about, I think is very apt. Is there anything, I mean, from my reading and my understanding of what's happening, there is an explosion of new information coming into the world, and we're seeing a lot of questions being asked now that were never asked 20, 30, 40 years ago. It's an exciting time to be alive. Is there anything, do you think, that you'd like to convey to people over and above what we've said so far about where we are?
About where we are? As I feel it, we may have gone through the turning point already.
Wow.
So that the destruction of old systems has probably mostly come to an end. And in parallel, new structures are building.
Yeah.
Already. And yes, it's our responsibility to watch what we support. Yeah.
Oh, yes.
We can always try and figure out the old question, who benefits?
Yeah.
Of what's going on. Or even if you go to the Christian tradition, you will see the outcome in the people's actings.
In their acts, yes, in what they do. Yes, any tradition, really, we should say.
Yeah.
Any religious tradition has its outputs that aren't necessarily good.
Yeah. So this is, I think, what we should try and observe and watch every time. What is the goal? Can we figure out what the goal might be?
And is that something we want? Yes. Yes. Well, I think that's a big question. I think that's another talk entirely.
Yeah, maybe.
At another point. But it's a wonderful one to kind of leave us with, I think. And I love that, what do we want, let's look at who benefits. I think that's a really powerful statement, which will leave me thinking a lot from this moment. So thank you so much for agreeing to talk with me today, and it was wonderful to connect with you again. And I'm sure, well, we'll keep an eye on the comments, because I'm sure people will comment, as they always do. And thank you so much.
Yeah, thank you so much. It's always inspiring when we come together and try to share some of our thoughts.
Yes, I think there is a
make them.
Well, there is something that kind of is greater than the sum of the parts when two people come together. I always think that, and that's the beauty of relationship, isn't it? Which is a mathematical concept, actually.
Right.
It's everything. All right.
Yeah.
If people want to contact you, how would they do that?
How would they do it? Let's put my email address.
Okay, perfect. We'll put that in the description. Yeah, lovely. All right, well,
that's probably the best.
Thank you very much, and
thank you so much.
Take care, everyone.
I hope we speak soon again.
Indeed, I'm sure we will.
Bye.
Bye.